Hi everybody, in this lesson we'll go through the write function. So the objective of this lesson is how do we use the write function, and then we'll go a little bit deeper into understanding how the write function works. This is important as in the future you'll be using the write function a lot of times. The first parameter in a write function is fd. So what is an fd? What does it expect? It expects an int. So that means when you use the write function, your first argument has got to be an int. When you pass in the argument 1 as the first parameter in write function, the function will write to a standard out file, which then outputs to the screen display. In the future, you might use 2 as the argument for fd. This is when you want to separate the standard output messages against the error messages. But for the moment, we will just use 1. Next, we come to the second parameter of the write function. This is where most people get confused. Why? Because this parameter expects an address of where the data to be processed is stored. You could actually write a hexadecimal number as an argument for this second parameter of the write function. However, this is not typical. What you would do is to declare a variable of data type char. In this case, we will declare a variable called c, and c is a char data type. Thereafter, we will use the address of c as an argument to pass into the write function. When you use the ampersand operator before the variable c, it means the address of c. Finally, we come to the last parameter, which is count. Count expects a size t data type. What is a size t data type? Basically, it is a number. And this number is the number of bytes starting from the address passed in the second parameter to be processed. If you are writing 1 character, then it is 1 byte that you are writing. And there you have it. This is the write function that you will use. Let us take a look at how we will use the write function. Before doing that, remember to include the uni_std.h library. In the main function, we will first declare char c. We will assign single quote a single quote to c. You might be wondering why use a single quote instead of a double quote. We will come to that later. Next, we will use the write function as what we had mentioned before. Remember, c is preceded with an ampersand. This means we are actually passing the address of c and not the actual value of c. The output, as expected, would be the capital A. Let's break it down further into what these characters actually mean in the memory address. First of all, let us imagine what happens in a computer memory. In this table, we have the address of the memory, and in the right column, we have the value of what it holds in its memory. When we declare char c, c is given a memory address. In this case, we have created an arbitrary memory address seen here. Next, we assign a to c. What happens when we use a single quote around the a? It tells the compiler to look up the ASCII table, and in the ASCII table, you can see that a has a decimal value of 65. And actually, what is being held in the memory address at c is not the value a, but actually the value 65. So now we will call the write function. The first argument, 1, will send whatever it has processed to the standard output. The second argument, ampersand c, would be the starting address of where this write function should process whatever has been passed to it. And in the last argument, 1 is the number of bytes it will process. So now the write function would display what it has processed. As you can see, it displays a instead of 65. Why is that so? This is because the computer translates the value 65 to an ASCII character. and this character is the capital letter A. So as you can see in this code that we have, A is no more assigned to C. Instead, we have given this C a value of 65, and the output is the same. So let us now try assigning 66 to the variable C. The output would now be B.